In this video, we're going to look at an example of a full confidence interval and talk about a few of the properties behind a confidence interval. So it says, use the following information to answer questions 1 through 5. In a recent poll of 1,200 randomly selected Massachusetts residents, this is done without replacement, 588 said they support the 2024 Summer Olympics being held in Boston. And number one, we want to know what is the sample proportion for this scenario. What is p hat? So to find p hat, you take 588, your number of successes from the problem that said yes, divide by the sample size of 1,200. So 588 divided by 1,200, as you can see, is 0.49. In our sample, 49% of people said yes, I would support the Olympics being held in Boston 2024. Now, this is only from a sample of people in the state of Massachusetts. If we were able to talk to every single person in the population, it could be a little bit lower or it could be a little bit higher. Therefore, we want to construct a confidence interval. So the second step is to show that the conditions of the central limit theorem are met. First condition, I need a random sample that is met because it says we had 1,200 randomly selected people. Also, a poll by definition should be random. My success number is 588. That's the number of people who said yes. My failure number is 612. Just take the sample size and subtract the number for your successes. Both of these are met because they are over 10. Because of this, I get to use the properties of the normal distribution. The third step in a confidence interval, and the third question here, what is the margin of error using a 95% confidence level? So a 95% margin of error is 1.96 times the standard error. And you'll get this formula on the test. You don't have to memorize this. You'll be given the z-critical value. But you can enter this in all at one time, and you should get 0.028. Just to show you on my calculator, go 1.96, then grab my square root by hitting second x squared, and I'll type in the rest. So I get 0.028. And then for my final step for confidence interval is to actually construct it. So we want to report the 95% confidence interval. To do that, you take your p hat, your sample proportion, minus e, that's your margin of error, then take those same two numbers and you add them together. So 0.49 was p hat, minus 0.028 from up above, that's 0.462 or 46.2%. Add those two numbers together, 0.49 and 0.028, and that's 0.518 or 51.8%. I can interpret this. I could say we are 95% confident, based off of this given confidence level, that the true population proportion of Massachusetts residents who support the 2024 Summer Olympics being held in Boston is somewhere between 46.2% and 51.8%. If I could somehow talk to every single person in the state of Massachusetts and ask them if they would support the Olympics being held in Boston in about 8 years, I'm 95% sure it'd be somewhere between about 46.2% and about 51.8%. Reminder that you can do a lot of this on your calculator. If you go to Stat, Tests, scroll way down the list to letter A, in the wrong spot, Stat, Test, letter A, the one prop z int, just hit enter. X, my success number, the number of people that said yes was 588. N, my sample size was 1,200. Leave my confidence level at 0.95. And so this 0.4617 would round to the 0.462. 0.518 stays the 0.518 as we saw. My p hat is 0.49. And I can get my margin of error from here, I don't need the formula. If I subtract these first two values, if I say 0.49, the p-hat, subtract the 0.462, I can work backwards to get that margin of error of 0.028. Final question for this review video says Jay and Clay need to improve their statistical study to calculate a confidence interval regarding the percentage of the population that would buy an electric car. Jay says they should raise their confidence level from 95% to 99%. Clay says they should increase their random sample size from 100 to 250. Who is correct and why are they correct? So essentially, should you raise your confidence level or should you increase your sample size? As has been mentioned several times already in previous videos, you want to increase your random sample size. So Clay is correct. Increasing the sample size will improve the results. It will allow us to be more precise. All right. We'll have a narrower confidence interval. To show you how, if you go to stat tests, letter A, let's say 10% of the population would consider buying an electric car. So if the sample size was 100, I would expect about 10 people, or 10%, say yes, I would buy an electric car. And I'll leave this at 95%. That's the typical value. So if I construct this, my confidence interval ends up being 0.041 to 0.152. So with n equals 100, we have 0.04.16. So 4% to 16%. But let's say I bump this up to 250. If I go to stats, tests, letter A, again, still 10%, 25 out of 250. So the same sample proportion, but this time I have a slightly narrow interval, be 0.06 to 0.14. So I'm more precise. I have fewer options. I think instead of 4% to 16%, it's 6% to 14%. I don't think it's 5% or 4% anymore. I don't think it's 15% or 16% anymore. I think it's somewhere between 6 and 14%. Increasing the sample size is the route to take statistically.